Hi everyone, I am Dr. Kambir from GeoTopia Academy. Today I am solving AMC 8 2026 problems together with Yusuf, a grade 8 student. Let's get started. Problem number 1. So this is a arithmetic problem. Yusuf, how should we start? What's the best way to
So
attack
first,
this problem?
when you have this type of problems with a lot of uh, numbers in it, first I count how many numbers are there and
Okay,
group them and solve them piece by piece and combine them.
group them piece by. So we
So,
can group first three,
yeah,
possibly.
first three,
First three.
second three, third three, and fourth three.
What is the value of first three?
The first one is going to be equal to 0.
Second three,
Is going to be equal to 3.
third three,
Is going to be equal to 6.
15, 6. And then fourth three groups will be
9.
9. Then we can just add up them together and
We
that's
will
going
get
to be 18. So great. Number 1, a very nice arithmetic problem. Bunch of numbers, Yusuf. So how should we start these problems? So let's see.
so I think we can group the numbers together
So
with
what about this? How many one we have?
5.
What about here?
5 ones, 5.
Oh, 5, 5. Very good. What that means?
4 times 5.
So 4 groups of 5, right?
Yeah, 4 groups of 5.
Plus, that was good. Let's see. What about the other one? What about, let's group twos. How many twos do we have, Yusuf?
3, 3, 3, and 3. So
That means
4 times 6.
4 groups of
4 groups of
6. Then finally, the center would be,
3 groups. No, 1 group of 3, which is 3 times 1.
or 3 groups of 3, right?
Yeah,
3 times 3. Okay, great. This guy is 20.
20,
This guy is,
24,
this guy is,
9,
they add up to,
53.
that is another good arithmetic problem. Seeing the grouping, and we have multiple strategies we can approach differently, but we saw vertical, horizontal. It came up very good groups, right?
Yeah.
Very nice. So number 3 is look like geometry problem. So let's try to understand the problem. We have 24 centimeters long wire, and we are going to understand. So he wants to bend it, form each of the following shapes one at a time.
Yes.
So Yusuf, regular hexagon with side length 5 centimeters. How
So a
many?
hexagon has 6 sides, and 6 times 5 is going to be equal to 30, and it will not be equal to 24 centimeters. So we can eliminate the hexagon.
Can eliminate hexagon. That's good. So good idea. Let's take a look at the second one, Yusuf. A square with what? Let's see, a square with one side is what?
One side,
No, sorry, the area is 36.
area is 36.
Therefore, the one side has to be
6.
because
If you multiply 2 sides,
mhm,
add a square, you will get the area. So 6
area.
times 6 is 36.
Therefore, the second one
Was okay
possible because
because
if
it's
you
going to
add
have,
if you add them together, right?
yeah, 6 times 4 is equals 24 and will be just enough.
Therefore, enough. Okay, Yusuf, let's take a look at a right triangle. What is right triangle, Yusuf?
Like half of rectangle. So, and
Mm-hmm.
legs are the shortest. So I'm assuming the height is 6
Mm-hmm.
and the other leg is
8.
8.
Do we know that this is called a Pythagorean triple? What is the hypotenuse? Length of hypotenuse?
So a squared plus b squared equals c squared. So 6 times 6 is equals 36 and 8 times 8 is equals 64.
Mm-hmm.
36
Or
64 is 100 and 100 square root is equals to 10.
or we know that this is a special triangle or special Pythagorean triple,
Yeah.
right?
6, 8, 10. Right triangle.
Mm-hmm. Are we okay for this one? For 24 centimeters?
So if we combine them, it is going to be equal to 24, and we're good with that too.
That will be okay. Wow, nice geometry problem, right?
Yeah.
Mhm. So let's move to number 4. Yusuf, number 4 is a percentage problem, right?
Yes.
What is the good way of approaching a percent problem?
Always have 100%.
Okay, great. Let's start with 100. I'm going to start, Yusuf, 100 and then increase, make it increase at 20%. If I
I
increase 20%, 100 plus, what's 20% of 100? Of course, 20, right?
Yes.
That's going to be what?
120.
120. Good. Then increase.
I think it decreased first time.
Oh, the first time decrease. Oh, sorry.
Yeah.
So let's good. First time we are making decrease, right?
Yes.
Not increase. Good. That's okay. 20%. If the 20% decrease happen, what's gonna happen?
It's going to be equal to 80%
Good. Then increase happen.
by 50%.
What is the 50, 80, 80 divided by
40.
240? That's going to be
120%
so.
of the original amount is what he gets by the end of August.
Yes, that is going to be,
Our answer.
yeah, 120%. Okay, that was good. Decrease, and after increase, then we can find the 120% of original amount. Great. Okay, now our famous distance formula. What is use of distance formula?
Rate times time equals distance.
So I'm going to make it this one, right?
Yes.
Driving time. What is driving time, Yusuf?
Driving time is 40 miles per hour.
And then distance. So drive. We can find the drive. This is speed, right? This is speed, right?
Yes.
Driving. And then the driving time, distance over speed, right?
Yes.
That is a normal. The normal one is what? 2
Normal,
point 2.5, right?
yeah,
If
2.5 hours.
if he didn't stop, right?
Yes.
But what about lunchtime?
Lunchtime was lunchtime was 0.5 hours,
Mm-hmm.
which would be 30 minutes.
30 minutes. It's clear, right? Is
Yeah.
just 30 minutes. Okay. Very nice. Great. Okay. This is also a nice problem for another uh, distance equal speed time, driving time, right? Great.
Yes.
So number 6, another geometry problem. So what are we trying to, Yusuf, could you summarize this problem, please? We have a large, big rectangle, outer rectangle and inner rectangle, right?
Yes.
And then what's our first goal?
Our goal is to take the black areas that we have maximum access.
Mm-hmm. And the area is what? The total area is, larger area is what?
The total area is 80 square meters.
80 square meter, right? So I want to also find the dimension of the inner rectangle. So Yusuf, this one is 1, right?
Yes.
And then 1 up and 1 down, this is going to be 6, right?
Yes.
And what about 1 right and 1 left?
Which is going to be 8.
8. Then the inner dimension is going to be
6, 8 times 6, which is going to be equal to 48.
okay, 48. Great. That is inner dimension. Then how can we find the shaded area? Shaded area would be,
We're going to divide 48
or AD minus
48,
48. That's going to be
32.
32. So what are we trying to understand, Yusuf?
We're trying to understand what fraction of area, like how many percent
Mm-hmm.
can he access?
So we are going to make it possibly so you need the area of shaded area over the total area, right?
Yes.
So that means 32 is shaded area, 80 is total area. But we don't have these choices, 32 over 80. Then we need to reduce the fraction, Yusuf. How can you reduce this fraction?
So we know that
Let's say 32 divided by 8, divisible by what?
it divisible by 16.
16. Oh, you are dividing by 16 directly. Wow, that's good. It's a good jump. I was thinking going step by step, but this is okay. That means 2 over what?
2 over 5.
Wow, that was good. 2 over 5. 2 over 5. Nice. Which is about 4 over 10, which is about 40%, right?
Yeah.
But it doesn't ask the percent, it asks only fraction, right?
Yes.
Okay, we are doing great so far. Number 7.
Mika would like to estimate how far she can ride with a new model of electric bike on a fully charged battery. She completed 2 trips totaling 40 miles. First trip used half of the battery, while the second trip used 30% of the total battery power. How many miles can this
So,
electric bike go on a fully charged battery?
so let's see. So we are going to do first trip. The first trip is 1/2. That
Yes.
means 0.5, right?
Yeah.
Second trip,
It's going to be 3 over 10, which
which
is
is
0.3,
0.3. When you combine this one, is going to be what?
0.8.
0.8. How many miles?
40 miles.
40 miles. So 0.8 power, right? 40 miles. So
Yeah.
we need to understand full battery, which means 1, right?
Yes.
So 1.0 or something like that. So what about, I need to understand, what about 0.2, right?
Yeah.
What is
So
the connection between 0. And 0.2? And then I can coordinate units, right? So you divide it by what?
you divide it by 4.
And you divide it by 4.
0.2 equals 10 miles.
When you add them together,
50 miles.
50 miles, right?
Yes.
It's a nice problem, which is very a real life problem. So number 8, another percent problem and whole number problem. 70%. Yusuf, can you tell me what is 7? How do I write 70% in terms of fraction?
74 or just 70?
74 over
100.
100. That's why percent, right? Percent per 100.
Yes.
So this could be 100 people, right?
Yeah.
Out of 74. But we are looking for what?
The fewest, like the least amount of people who could have.
Least amount of people. Can I go one further step, Yusuf, to make it this one possible? Maybe what's the equal fraction, the next equal fraction?
The next equal fraction,
Mhm.
50 over
Fewer people. If out of 50, what?
37.
I think 37 is a prime number. I cannot go further. Therefore, I would say this amount would be what?
The highest.
The fewest possible, right?
Yeah, the fewest.
Fewest possible. I cannot divide it into people, different pieces. Okay, great. Now we are okay for this problem, right? 50 is a good answer overall. Just we are using the concept of percent, right? That's all. Very good. Ooh, a nice square root problem, Yusuf. Well, all of them are perfect square, which is good. Yusuf, can you tell me what is square root of 81?
9.
What about square root of 16?
4.
4. I'm going to make it this one. So 16 times 9 and square root of 81 times what?
16.
Which
81.
is which is 4. And that's okay. I can go different direction, but I would like to go this way, Yusuf. Uh, to make it clear, square root of 16, square root of 9, and square root of 81, and square root of 4.
Yes.
Then this guy is what? Tell me.
That guy is
4.
4
The
and
other one is
3.
at root 81, 9, root 4, 2.
2.
Well, what is the best way to reduce this fraction? I am thinking, Yusuf, this, if you cancel this one, is you get 3. If you cancel this guy, you get 2. That means 2 over 3 would be my final
Answer.
answer. Okay, good. Okay, very nice. Perfect square and square root. Oh, square root problem. Well, we are now number 10. So we need, so this is an interesting problem. So when we run into this kind of problem, right, we need to understand the problem first, and maybe visualization is better way to problem solving. So how can I visualize? Let's start. So which one is useful for us, Yusuf? Where should we start? From the
The bottom.
bottom. Okay, last information. Look, let's use this information. When I say O, right?
Yeah. Olympia
Olympia
is
is,
greater than L.
let's say the distance between Olympia and L is 6, right?
Yes.
Okay, good. I used the information. Good. Let's go. And what about the second information? Olympia finished 2 minutes ahead of Melina. That means Melina, where is Melina?
Is
Here, right?
yeah,
2 minutes before, right?
yes,
Then, but 3 minutes behind Pedro. Then where I am going to put Pedro?
in front of O.
How many
3.
minutes? 3 minutes. It's not drawn to scale, but it's overall. We are visualization is very important, right, Yusuf? Now we visualize the second part, right?
Yes.
Okay, we visualize the second part and we decided. And how I use the first piece of information?
We
Nico,
gotta find the highest Nico
11 minutes behind Pedro. What I am going to do, Yusuf, I'm going to go from Pedro to how many minutes behind?
11.
11 minutes behind, right?
Yes.
Is it okay to have Pedro here? No, sorry, Nico, right?
Yes.
11 minutes behind means what? Is technically there's also, that's okay, it doesn't matter, but this is going to be 2 minutes, right?
Yes.
So my visualization overall good for you, and we use all information overall, then our order seems okay, right?
Yes.
Then which runner finished fourth?
The runner who finished fourth is Luke.
Okay. Yes. First, second, third, and fourth. Okay, great visualization overall. And so yeah, visualization is important part of the problem solving process, right?
Yeah.
Okay, great. Well, after this problem, now we are going into another golden problem. Why I say golden ratio, Yusuf? Golden problem because this is the golden ratio. This is
Yeah.
called the golden spiral. This is this is called these numbers are called the Fibonacci numbers, Fibonacci sequence. Why this is important? Because I would like to take a moment to explain this one. One, one, two, three, five. And Yusuf, what is the next number will be? Do you see that this number is special number? It's called the Fibonacci sequence. Because when you see that this number one, what's one plus one, Yusuf? Two, right?
Yes.
One plus two, three.
5. 3.
And then two plus three, five. Then the next number is going to be eight. The next number is going to be
13.
13. This is a Fibonacci numbers and also called a golden ratio. Very important concept. Uh, oh, and then very interesting idea is golden ratio is a phi. It's called a phi, and then that's my favorite number. And then this is called also golden spiral. Okay, but let's see. What are we trying to understand?
We're trying to understand that the length of the curve.
Curve. Let's try to understand what we have here. What do we have, Yusuf? First,
We have
what?
uh
Semicircle.
yeah, we have a semicircle.
What is the length of the half of semicircle's length?
The rate
2 pi r. R is 1, right?
yes,
2 pi r divided by what?
divided by 2.
2. The blue one, the semicircle length, semicircle curve length, it will be only pi, right?
Yes.
Let's go step by step. Then what is my second, the green one? Green one is Yusuf is what? The is a it's called what? Quarter circle, right?
Yes.
And then 2 pi, what's the radius?
The radius is
2.
2.
And then should I divide by 2 or should I divide by 4?
4.
Because it's quarter circle, right?
Yeah.
Well, what is next, Yusuf? I'm going to go the now red one. The red one is another what, Yusuf?
Another quarter.
Quarter circle. Then what is the the length of the curve?
The length of the curve. The length of the curve is going to be
2 pi r
pi 2 pi times 3
over.
over 4.
Hmm. Are we okay for this one? Is it still 2 pi? 2 pi, right? And then
Yes.
2 pi r is 3, right? Are we okay? 3 divided by 4,
3 divided by 4. Yeah.
which is
0 point,
1.5, right?
yeah, 1.5.
Okay, let's go step by step. The final, Yusuf, what is final one?
The final one is we combine all of the terms and we get 5.
The final one is going to be what? The final one is, are we also thinking the longest one?
Yeah.
Joining the quarters, circles in orders. From shortest to long, this is the longest one, right?
Yeah.
That is going to be what, Yusuf?
That is going to be
5, right?
yeah, 5.
Then is also another, what we call another what?
And our quarter square. I circle, sorry.
2 pi,
2
uh, 2 pi,
times 5
5 divided by,
divided by 4.
just making sure we are not doing the area. I shaded something to make it clear, right? We are
Yeah.
we are trying to get this curve length, right?
Yeah.
Okay, good. Is it going to be what, Yusuf? 5 pi over 2.
Yeah. 5 pi over 2.
So technically this is 2.5 pi, right?
Yeah.
This guy is what?
1.5 pi,
Which is add up to
4 pi.
4 pi. So everything add up to what now? Let's try to get all of them. This guy, this guy, this guy, this guy add up to
Is 6 pi.
6 pi. What do you think? Very colorful, nice uh, Fibonacci numbers, golden spiral, and also we now learn Fibonacci numbers and golden ratio, Dr. Camber's favorite number. Great. Let's go to problem 11.
I think 12.
Oh, this one is 12. That was 11. Okay, very nice puzzle. Can you explain this puzzle, Yusuf? What are we trying to understand? What is the rule of this game? We need to use what, Yusuf? One, how many numbers?
We need to use 6 numbers and they will never repeat each other.
1, 2, 3, 4, 5, 6, and we have to use what?
1.
Ones, right? Okay, good. And let's see. And then the what is this number means? That it's a sum, right? Neighbor, the sum
Yes.
of two neighbors. Now we have to every game needs strategy, right?
Yeah.
What is the good strategy for starting? Which from the right, from the left, or somewhere top or bottom left or bottom right. So
Right.
right, okay. Why is right, Yusuf? What do you think?
Because we have the number 4, and number 4 could be used,
1 plus 3,
yeah, 1 plus 3 and 2 plus 2. It cannot be
or
2 plus 2, but
two.
it repeats.
But Yusuf, it could be 1 plus 3, could be one, could be top or bottom, or three could be. How do I know this one is
Oh,
which
you
one
have
is
6 at the top, and the sum of So if you have 1, 3, and the sum is going to be 6 with another number, it cannot be 3 because every
Oh, okay, that's good, very good. I like your idea. Therefore, this has to be what?
1,
Okay, very good. One and what?
3.
Okay, very good starting. I like your strategy from bottom. Then most likely if this is let's I see that overall something happening, but let's go from the down. I can see the answer, right? Okay,
Yeah.
let's see. This guy is going to just make sure this guy is going to be what?
5. 2.
So this guy is going to be,
6.
this guy is going to be,
4.
this guy is going to be.
5.
Great, because from the beginning we also made very clear, but we just want to make sure we are not messing up those numbers. Okay, now it's now clear, right? The top number, what digits must be placed in top circle.
Yes, it is all clear.
Yes. Now this is a interesting geometry problem. So first I'm going to visualize this problem.
Okay.
And I'm going to make it bigger. Okay. You are working now geometry, right, Yusuf, because you like to pass the geometry course. That's great. And then you got the GeoTopia 0.1? Sorry, 0.5? Yes. Okay, Yusuf, let's start. Here's the thing, Yusuf. I'm going to make it what? What's going on here?
You're gonna make a big square to see
Okay,
how many space does it
let's
fill up.
okay, that's going to be fun, right? Okay. Ooh. Okay, now very nice. Now let's try to understand. Let's try to understand what's this. This is half, 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 half. That's going to be one, right?
Yeah,
And then this is going to be what?
3,
And this is going to be
1,
one. This is going to be,
3,
this is going to be
1,
one. This one,
3,
one, two, three. Wow, that's good. And then this is going to be one.
and 3.
Actually, what do you notice? Four identical what? Four identical
Sides.
the triangle, right?
Yeah,
Side. Four identical, four congruent triangle, which is one time each one's the area is going to be what?
it's gonna be 1.3 divided by 2.
Then how I find the area of this shape, Yusuf? The the large square, right?
First, you have to find the big square, and then
Mm.
when you find the area of the big square,
Area of big square is 4 by 4, right?
yeah, 16.
Take away four small square, right?
Yeah,
That's going to be what? 16 minus
16 minus
4
5.4
times what?
times 1.3.
Are we okay?
Yes.
Are we doing any mathematical arithmetic mistakes so far? Each corner, right? So those four identical one will be we see that, right?
Wait, will the area of the triangles be 1.3 or 1.5?
One times 1.5, right? 1.5.
Yeah, because I was like,
So one times the base time height divided by two, right? 1.1 times 3 divided by 2, right?
yes,
1.5, 1.5, 4.5, 6, right? Total
yeah,
6, right? For triangle, and then the large triangle is 4 by 4, right? Sorry, right. A large
square.
square is 4 by 4, right?
Yeah.
16 take away 6, 10. I think that's a good solution because you could use what's called the coordinate geometry, or you could use find the Pythagorean theorem. Another way of doing it, you can find the Pythagorean theorem, use the Pythagorean theorem, get this guy root 10, root 10, and root 10, and root 10, and then root 10 times root 10. That's going to be root 100 is still 10, right?
Yes.
So we can solve this problem maybe different met using 5 different methods, but this is good. Completion, the finding the four congruent triangle would be good way. So
Yes.
okay, problem 14. So far we are doing great. And then so this problem we are going to use possibly power of algebra. Yusuf, what that means, the 3 equal spaced integer number on the number line.
So we're gonna have a number line.
So it's not 3 equal space, 3 numbers, right?
Yes.
This is a little bit the first part. This first part is hard to understand, right?
Yeah.
How can visualize this part, Yusuf? Can you tell me?
So we have a number line and it has three equal spaces.
How many numbers?
Three.
Three numbers, and then two
Two.
equal space, right?
Yes.
It's a little bit confusing, right? It's not hard to understand. 3 equal space integer number. Actually, there's two distance, right? Let's say if this number is a, the first number is a, Yusuf, and then distance equal space, right? The distance is d. What
Yes.
would be the second number?
A plus D.
Because we don't know those numbers, of course, is big number, right? It's not going to be 2021, right?
Yeah.
I don't know d, right?
Yeah.
Okay, good. I jump. D is represent distance, right?
Yeah.
Okay, the first number, the second number. What about third number?
It's gonna be A plus 2D because they're the same space.
I go D more, right?
Yeah, one more D.
One more D. That means that's going to be
Plus
A plus 2D. And then the second number is A plus D. And then the third number is what?
third number is
Is A plus 2D.
yeah.
So what we call Yusuf power of algebra. That's why SMP2 is called the standard for mathematical practice. I teach teachers. I encourage them to use power of algebra. That means, Yusuf, let's make an equation out of these two pieces of information. What's the first equation, Yusuf, I can get?
The first equation is uh A
The
plus
first, the
plus
first and what? The first plus what?
first plus second
Second
equals 40.
equals what?
Equals 40.
40. Okay, that's the first equation, right?
Yeah.
I'm going to make it mathematical notation. So that's good. And what about the second equation, second piece of equation? We can use the second piece of data. What's the second? Go ahead. While the sum of the second,
The sum of all three numbers is going to be equal to 60. So A plus
or second and third, right?
yeah,
A plus D plus what?
plus
A
A
plus
A plus 2D
2D equals what?
60.
60. So we are now okay for this one. Okay, very good. From the first equation, Yusuf, how I get the first equation, the information? It's going to be what? 2a plus d equals
Plus
what?
D equals 40.
40. Then this is going to be 2a plus what?
2a plus 3d equals 60.
Let's say this is the equation 1. This is the equation 2. So when the idea is here, I can use some arithmetic techniques, but I prefer to use now algebra. So it's going to be easy when I say this. Equation, use of equation 2 minus equation 1
So 60,
minus 40, right? 20.
yeah, 20.
20. When I do equation 2 minus equation 1, do you see that cancellation will happen?
Yeah, we will cancel the a's and we will cancel 1d. So 2d equals 10.
No, 2d equals 20, right?
2d equals 20 and d equals 10.
This is very important. Right? We found what?
We found the distance.
Distance. So how they jump, right? If
Yeah,
you find d, Yusuf, you can put the first equation, right?
yeah.
How? The first equation, how you put the
First
first
equation
equation?
was
10.
a, yeah,
2a plus 10 equals 4d.
2a equals 30, a equals 15.
So technically, this first number is 15. The second number is 25. You jump 10. You jump another 10. 35.
Yes,
So then if you add them together, you will get 75.
75.
So we have multiple different ways of doing this. But I prefer to use the algebraic notation, and I show all the 7th grade, 8th graders or 9th graders power of algebra, right? Power of algebraic representation.
Yes.
Great. Now, Yusuf, I'm going to have you this session's final uh, final problem solution, page number 15. Can you just quickly explain the problem, what's going on, and then start solving that?
So we have cubes have that have two faces that are gray and four faces that are white. We want to glue the cubes together and have no gray sides visible. And we're trying to find the least amount of cubes that is needed to find to make no gray sides visible.
Okay, great. So how we do that? So least amount of number. So because we don't have to try it or 2 or 3, right? Let's try 4. How how do you glue 4 cubes to make this happen?
So we're gonna use the gray sides to form like a skeleton inside that will not be seen.
Okay. What's the first step?
The first step is just have a like yeah, we're gonna have a cube that a white side is looking downwards
Mhm.
and
You glue 2 together, right? With
yeah,
their
you
what we
glue
call
both
the
of them together with uh
their gray shapes, right?
yeah,
Let's say these 2, right?
yes.
Okay, great. Then what will be the step 2?
Step two will be we will create a reflection of this.
Mhm.
and we will glue the gray sides together,
Mhm.
and we will use and it will be no gray sides visible, and we will use four
Mhm.
cubes to
Yes.
make a shape.
Now, now this time, Yusuf, do you see that you make those, you explain that together, right? This is now no visible gray, right?
Yes.
Okay. I think that's a good solution. Thank you for sharing your solution. That's all first 15 problem. I hope you enjoy. And if you like to do more practice, seventh grade, eighth grade students, we have, as a Mathtopia Press, we have great resources for you. First one, of course, Math Fluency, grade 7 to 9, and also GeoTopia, great resource for 8, 9th grade geometry, and Math, Middle School Math Challenge book. And for more practice, explore these AMC 8, AMC 10, 12, and further, you will see Mathtopia Press Amy prep books available on Amazon. So thank you and good luck with your